In this week's lectures, we get introduced to algorithms and especially efficiency and analysis of algorithms. This is a very interesting topic. So, what are algorithms? An algorithm is a step by step procedure used to solve a problem. But making sure the developer is using the most efficient algorithm is very crucial, no matter how fast computers become or how cheap memory gets. So, for any problem that we solve, there are many ways to solve the problem, right? It's not that each problem has only one solution. You have only one algorithm. There are many algorithms, and developers have many options to choose from. So for example, if our task is to find a particular student ID in a list of many student IDs, so there can be many algorithms or many approaches to finding that student ID, right? So how do we choose the right or the best algorithm for that? Since many are available, and also we know that computers are getting faster and faster, so you might think that, oh, computers are getting very fast, so it shouldn't really matter what algorithm you choose. It will, the fast computer will be able to solve the problem with that algorithm anyway. Or you could think memory is getting cheap anyway, you get more memory in smaller chips, right? So you may also think, oh, these resources don't need to be, we don't need to stress about these resources now since our computers are fast and memory is cheap. But it does make a big difference, no matter how fast the computers are or how cheap memory gets. So in order to determine how efficiently an algorithm solves a problem, we need to analyze the algorithm. And that is what we will be doing. Order is something that we will learn about. So order helps group algorithms according to their eventual behavior. To produce a computer program that can solve all instances of a problem, we must specify a general step-by-step procedure for producing the solution to each instance. So for example, that's talking about, let's say we have a list of student IDs and we want to find a particular student ID in that list. So that is the problem. You given a list of student IDs, be able to find a particular student ID. And then an instance of it would be, a particular set of the student IDs. Another instance would be a different set of student IDs, and then another instance would be a different set of student IDs, or maybe a set of other strings and not student IDs. So the nature of the problem, right? So you have a general problem which requires a general step-by-step procedure, and that step-by-step procedure, that is what we call the algorithm, right? So we say that the algorithm solves the problem. The importance of developing efficient algorithms. So efficiency is an important consideration when working with algorithms. A solution is said to be efficient if it solves the problem within the required resource constraints. So for example, given the reasonable time and the compute power that's available and the memory that's available to work with, for us to work with, all of that needs to be taken into account. And then we can say whether the solution is efficient or not. Okay, so since one problem can be solved by many different algorithms, it may be important to determine which one is the most efficient. Example, searching with a sequential search and binary search. Let's look at the sequential search and the binary search algorithm. Okay, so what is sequential search? The sequential search algorithm, it begins at the first position in the array and looks at each value in turn until the item is found. How about the binary search algorithm? So the binary search algorithm first compares X with the middle item of the array. If they are equal, the algorithm is done. If X is smaller than the middle item, then X must be in the first half of the array, if it is present at all, and the algorithm repeats the searching procedure on the first half of the array. That is, X is compared with the middle item of the first half of the array. If they're equal, the algorithm is done, etc. So if X is larger than the middle item of the array, the search is repeated on the second half of the array and not the first half. This procedure is then repeated until X is found or it is determined that X is not in the array. Okay, let me show you this example on paper.
Let's say we have an array. It has 32 numbers in it. It is sorted in this order, starting from smallest going to the largest number, right? So let's say we have the array 1, 2, 3, 4, 5, 6 all the way to 32, and we are looking for a particular number. Let's say we're looking for the number 32. We know that it is right at the end, but for the computer to find it, it needs an algorithm. So using the binary search algorithm, what is its approach? What is the binary search approach? For binary search, what it does is it will keep halving what we have in the array. So it's first of all going to halve here. And since we know for 32, there are going to be 16 numbers on this side and 16 numbers on this side, right? So if there isn't one particular number that's right in the middle, we're going to take the lower number that is there. So when we first get to the half, we pick the lower number if it's not a specific, if the half is not a specific number. For example, if it was 31 numbers instead of 32, then our half would fall exactly on 16, right? But it's not. Anyway, so in this kind of a scenario, we pick the lower number, which is 16. So this is, let's say, our first search. We have checked the 16. So what we do then is we check, is the number we're looking for, which is 32, is it on this side of 16 or is it on this side of 16? Since we know it is ordered, right, it's got lower numbers on this side and higher numbers on this side. So 32 is definitely on this side of 16, right? So then we no longer worry about this side of the array and we just focus on this section. Okay, so then we do the same thing again, half, and check what is the number directly on this half or on this side, the lower end of this half, and we will find that the number here is 24, right? We'll have 16, 17, 18, 19, 20, 21, 22, 23, 24, and then 25, 26, and so on. So our half here again is 24. That is our search number 2. Then we compare again, is 32 on this side of 24 or on this side of 24? And we find that 32 is on this side of 24, right? Because it's bigger than 24. So then we no longer worry about this, all the numbers in between here. And we just search this section of the array. So we do the same thing again. We go half and we find the number here. The half here is 28. We have 24, 25, 26, 27, 20, 28, and then 29, 30, 31, 32, right? We find 28 here. This is our search number 3, and we do the same thing, compare. The thing we're looking for is 32. Is it on this side of 28 or on this side of 28? And we know that it's more than 28, so it's on this side. So we don't care about this part of the array anymore, and we search on this side of the array. And we do the same thing, we half it, and what do we have here? 28, 29, 30, 31, 32. So our middle here is 30, right? And that was our search number 4. Then we do the same thing. Is 32 greater than 30? Is it on this side or on this side? And 32 is on this side of 30, right? So we no longer care about this section, and we find the half that would be in here. And in here at the center would be what? 30, 31, 32. So it was 31 in the middle here, which is our number 5. And then we check, is 32 on this side of 31 or on this side of 31? And we know it's more than 31, right? So it's on this side. And so we find what's in the middle, and there is only one thing. So that was our 6th search there, right? And we have found the element that we were looking for, given the element is in there.
Let's take a look at the sequential search algorithm now. Write the algorithm of sequential search for array of integers. right? So let's discuss that on paper now.
Let's look at the same example, but then use the sequential search approach. Let's say we have the sorted list or sorted array, and we have these numbers from 1 to 32, and we're looking for the number 32. How would this search go? Here we would look at the first number and check, is this 32? Yes or no? No. Go to the next item. That was the first check that we did. Then look at the next item. Is this what we're looking for? No. That was the second thing we did. The third thing we do is we check this one. Is this 32? Nope. So that's our third search. Then we look at number 4, the next number. Is that this, which is our fourth search? No, it is not. And so we keep doing this until we reach our 32nd search. Then we check, okay, so before that we would have checked our 29th search, which is, okay, checking, is this 29 the same as 32? No, it is not. It's not a match. So check the next one, which is 32. Sorry, not 29, 29, then 30, then 31, right? So it would check all that many times. And then finally, the 32nd check, we will try to match. Okay, so is this 32 equal to 32? Yes, it is a match. So we have finally found the thing that we were looking for, and we will see that we have actually checked many times. Actually, exactly the number of items that were in the list. That's how many times we had to check.
Let's take a look at how the code would look for sequential search in Java. Again, given the algorithm, you can write your code in various ways, and then you try to write your code as simply as you can. And you can try out a few ways. You will find lots of versions of the code online, so I recommend you try them all out, as many as you can find, and try to understand how they are working, what each line of code means. So let's look at this sample one. Here we have a sequential search method, right? So sequential search, and then here open parentheses and close, right? So all the way here it's receiving some parameters, right? So the first one is a key, a comparable key that it is receiving, and the next thing that is receiving is an array list. Okay, and there's some details here, like the array list is going to contain elements in it that are going to be able to get sorted using the comparable interface. Anyway, that is for you to try out when you actually do the programming of it. But to get a gist of it, the sequential search method is going to accept two things in it. One is the key that you're trying to look for. For example, the x equals 32. So 32 is the key that you're looking for. Just an example. Okay. And the array list is going to contain some type, some objects, right? So for example, integers. And then receiving the two things, the array list and the key that you're looking for, what is the method going to do? Here is the main part of the algorithm. So here we start off with an index or lock, right? So we use the word lock or index to keep track of which index in the array list, in the array we are looking at, right? So let's say we start with the lock being at 0, or the index of the array being at 0. And then we have a while loop. So while the index or the lock is less than the size of the array, here the array list is actually called in, right? So the name of the array list is in. So while lock is less than the size of the array, and this part is trying to evaluate whether the element at that index or the element at that lock is equal to the key, right? If the thing at that index is equal to, for example, 32 that we are looking for, right? And the compare to method actually returns 0 if it is what you are looking for, right? If the element at that index or at that lock is equal to the key, or it matches the key that you pass to it, it will return 0. Otherwise, it will return -1 or +1. So if it returns 0, that means it is a match, right? So if it returns 0, so 0 is not equal to 0, so which means as long as it is not a match, right? So while you are still within the size limit of the array and you haven't found the match, increment the index or increment the log. Okay, so that's basically what's happening in this while loop. So increment the log, which means increment the index, right? So the next check you do is for index or log at 1. So at index or at log 1, um, check as long as you are within the size limit of that array, and if you have not found a match, then again you increment your index or increment your log, and you keep doing that until one of these become false. um, for example, if you suddenly reach the end of the array, then this will become false, right? The index or the log is no longer less than the array's size, right? So this will become false. On this side, when would this become false? This would become false when you actually do find a match, right? When you get 0 returned here by the compare to method, and so 0 is not equal to 0 becomes true, then you would no longer increment and you would just exit this while loop, which means you have found the thing that you were looking for. Or after completing this, you would check, which means when you run out of the indices, right? When you have reached the end of the array list, then you would exit the while loop and you would reach this part, which is checking if the index of the log is greater than or not equal to the size of the array. Then you have reached the end of it, and you just return -1. So log is set to -1, and you return that. So wherever this sequential search function or sequential search method is called, it would return -1, and the receiver would know that, oh, -1 means that it was not found. Otherwise it would return, otherwise log would be the value, the index where it was found, right? And that is what would be returned, the index of where the key was found. Okay, so that is how the sequential search in Java would look. Of course, there are other ways to implement it, and I recommend you try various techniques out. The binary search algorithm, we have had a look at how it works on paper. Let's just go through the code and how it would look in Java. Right, so let's say we have a binary search method. It's going to again take in two parameters, the key that we are looking for and the array list, called, for this method, we're going to call it in, right? And then to keep track of the individual index that we are looking at, again, we have our index or log, and it is starting off with -1. Also, we have the variables to keep track of the other indices, which were the mid, the low, and the high, right? So the mid is every time we divide or break our array or array list in half, we have to keep track of where that mid is, right? And that's going to change every time. So first of all, it's going to be the exact middle of the whole array, and then the next time it's going to be the mid of either of the halves, and then the next time it's going to be half again, and so on. So that will keep changing, and we keep track of the middles using this mid variable. We also have our low, and low is going to start with 0, so it's going to start on the right on the minimum end of the array list. And we have a high, which is the index of the maximum, the right far the high end of our array list, right? So here these three let us keep track of our indices, the low, the mid, and the high. here this is how we set the values. So the low index starts with the 0, and the high index starts with the maximum index that we can have in that array list. So how do we get that number? We say the size of the array list, which for 32 numbers, right, 32 elements, the size returned is 32 because there are 32 elements, for example. But the final index is not going to be 32. The final index is going to be 31 because it's going to start from 0, right? So 0, 1, 2, all the way up till 31. That makes the 32, which is the size of the array. Then the 32 minus 1 gives us the last index, which is 31. Okay, so here at this point we have set the low and the high indices. What do we do then? Then we have a while loop to keep looping through the array. And in every iteration, what are we doing? We are checking two things. Firstly, we are checking low is less than or equal to high. Okay, so as long as the low is less than or equal to the high, right? As long as we are going in that direction, and our index that we are keeping track of from this end, from the low end, has not crossed the index that's keeping track of the high end. So that's what this part is checking. And we are also checking as long as log is equal to -1. So -1 is just telling us that we haven't found our key yet. We have not found the thing that we're looking for yet. So as long as we have not looked through all the indices, and as long as we still have not found our key, check these things or do these things. What are we doing? First of all, we are setting our mid. Mid is what? This is the index that is right in the middle. So how do we find the mid? We do our low plus the high divide by 2, right? Our low starts with 0 and the high is, for example, 31. So 0 plus 31 is 31, divide that by 2, and if we get a decimal, or if we write in the middle, which number are we going to take? We're going to take the floor, right? So not rounding off, not rounding up, but this is rounding down. Okay, so for example, if we get an answer such as 5.5, we're not going to round it off to 6, we're going to round it off to 5. Anyway, so mid value has been found. Then we are going to check if the array, the element that is in the middle, right, that is at this mid index. So the middle element, does it compare to the key? And this method is going to return 0 if it is a match. If the element at mid index is matching with the key that you sent to the compare to method, then it returns 0, right? So if it's a match, you get a 0. So if 0 equals 0, that means our log, or our answer, our x, is equal to mid, right? The index where our key is found is at the mid, this same mid index, right? So if we find it at that index, we say, okay, found the answer, our log is equal to mid, and then we wouldn't check the else. If we wouldn't check the else, we would go back up and we would check this. Low is less than or equal to high. Okay, yes, we haven't really changed our low or high, and log is equal to -1. So if we did find a match, we had set our log to mid, and our log would no longer be -1, and so this part would be false, which means we no longer keep iterating through this while loop, and we just return the index where we found the key, which was this mid. However, if we check this if condition, and no, we have not found the key is not found at the first mid index, right? So if this is false, we do not go and set our log to mid. Instead, we check the next else if condition. And what are we checking here? We are checking if um, the element that is in the mid index, right? If that element matches the key, um, if it does match, we will be returned a 0, right? If it did match, we would be returned a 0, which was here, and we would go into this. Anyway, so it would, in this case, not return a 0. It would either be a -1 or +1. If it's a +1, that means +1 is greater than 0, and this would be true. If it returns a -1, that would mean uh, this is false, and we would do this part. Okay, so what is happening here? Let's say we do get returned +1. So +1 is greater than 0, true. So we come in here and execute this part, which is high is now equal to mid minus 1. What does that mean? That means our high was initially at the highest end, right? Just imagine that we have this array list. Our 0 is the low, then we have the mid, then on this end we have the high, right? Um, and at this point we are checking if the mid is matching with the key. The compare to method compares the numbers, and if it is if it is less, then it will return a +1, right? So here we say, okay, this is true, and so we set our high to mid -1, meaning we have moved our high all the way from the maximum high that we had in the array all the way down to the first half, right, to the mid -1, which means we have completely disregarded the second half of the array, which was on this side of the mid, right? Which means our the key that we're looking for is actually less than the thing that was in the middle, and so we are going to further divide and check inside this side, the lower half of the array list. And so our high is then set to the mid -1. Okay, and then we would go back up and then do the same thing again, set the mid again, which would be half of this first half of the array, right? And then we do this check these conditions again. Anyway, if this was less than 0, then this would be false, and then you come here and execute this else part, which is saying basically our key is actually more than the mid that we had found, and so we set our low to mid +1. So we move our low index, which was 0, move it from move it from 0 all the way to whatever was the mid +1. So we have now set our new low, which is the mid +1. So now we are no longer considering the things on the on the lower half of the array list, and we are going to further look into the higher half of the array list, and we go and uh, iterate through the while loop again until we just repeat the same thing, and at some point we would find a match, and we would set the lock to the mid that we have found, and we would return that lock. But if we have iterated through the entire array list and we still have not found the lock, meaning we have not set a new value to the lock, what would be returned? The initial value of the lock, which was -1. And so if the binary search method returns a -1, that tells the caller of that function of that method that, oh, in that array list, that key does not exist. Okay, so that is how the binary search method or algorithm looks in Java. Now I know you will find different versions of this code online, and I recommend that you try them all out and understand them.